How many here know what Auth0 or Okta is? And how many of that are just Okta because you see it every morning? Okay. Auth0 is a part of Okta, and it was an independent company till 2021 when Okta acquired us. We focus on developer productivity and building security tools for developers. So we build authorization products, authentication products, and the entire suite. And I've been at Auth0 for about roughly 9 years, 2 months at this point. So I've been in this industry for about 15, and that's allowed me to basically see through the first SaaS transition and now the AI agent transition. And so as we're talking to agents, we're talking about agents, we're working with companies, we have some insights in it. I would love to chat. This is a workshop, but it's also like a more open session. So I'm very open for questions because I'm sure a lot of folks here, they don't need a Auth 101 or they don't need an AI 101, but the intersection becomes extremely blurry. And I do want to thank Goose, Windsurf, Claude, and a bunch of agents that made this demo and workshop possible. So we all hear all of these hyperbolic statements like AI is going to eat SaaS, or AI is going to make this job disappear, or AI is going to make that job obsolete, right? And at a philosophical sense, we know, yes, technology moves forward, and therefore AI will change things. But then between ChatGPT going from a website that you would ask to do your homework to now writing Google Docs that you do your homework, that ChatGPT and AI is still interacting with the digital world. And so this talk is largely focusing on digital identities, digital conversations. And the other part, which I like about this slide, is how many of you and how many of us have built a very cool workshop, including my current one, and then you have to do the disclaimer. This is an amazing MCP server, but you have to go to this dashboard, click here, click here, click here, copy this environment variable, paste it here in a JSON file. And I'm sure folks are experiencing that. And so that's what we want to simplify. And we've kind of like isolated down into 4 sets of problems. And I'm going to switch a lot to my workshop between this, but I'm using my slides to just do the talk track. If we think about like how most of us work, we use Jira, we use Microsoft Stack, we use Google Stack, and now I don't want to go to Jira. I want it to tell me what I should be focused on. How many here hate Jira? The screen of it, the UX of it, right? But we all use Jira because it's the only way to work with it. Whereas with AI, instead of us having to interact with applications directly, you now can just ask ChatGPT or Gemini. And these agents can talk to each other. And so before, which was just 5 lines of very clear access control, is now a delegation between am I requesting something to be moved in Jira, or is ChatGPT requesting it? Or is it Gemini requesting it through ChatGPT on my behalf? And those are the problems that we hear a lot. And we're talking to customers, we're talking to developers, and this becomes a very common pattern for us. And a lot of this goes back to we've completely recreated the entire stack. Before you had like a very nice agent, and I think this is so the workshop, if you want to follow along, it's very alpha. It's a much longer workshop. I've tried to squeeze it into the specific meaty guts and meaty bits for today. And what we're going to be building is we're going to start with a setup which is roughly your native app, right? You have a native app and you have a server. And I'm going to switch to Windsurf, which has the packages. So you have in there, you have an API client and you have a web server, right? This is very strong, very standard architecture. Your web client is going to call the API and it's going to make changes for you. How many here want to follow along, and how many here want to just, because it's 4 p.m., I'm also being mindful that not everyone wants to write hundreds of lines of code. is there a show of hands how many want to code along and how many would prefer like a more I code and you laugh when cursor does something messy session? Oh, sorry, Windsor. Okay. Okay, I code. Cool. Oops. I should have not signed up for that one. So in this architecture, and I'm going to bounce around slides because now I have to just walk faster. This is how our works have looked since forever. You have a backend, you have a front end, you have a worker. This is no different than we do today. So in here, I have a front end application. It's called Stock. And as I was writing this workshop, I was using the term stock trade. I found out that that's a term that's a registered company. So now it's called Trade Demo Pro, which nobody should be confused at. So I sign in, and now I can see my portfolio. I can place orders. I can create a trade, like the simple stuff, right? Like I can buy like 11, and I bought another LexCorp. These are all fictional stocks. Some time ago, Gemini hallucinated and created NVIDIA stocks, and in one of the demos, it dropped NVIDIA by 10%. That was terrible. And this is a full app, right? So if you want to follow along, you can go to workshop.auth101.dev, and you can also just go follow me on Sam Shrek on GitHub. And I'm going to keep maintaining this because this is my sort of go-to kitchen sink for all auth things. So this is the app part, and in the API server, it's written in Hono. It's very basic. There is nothing here is like real data. It's written in Drizzle, and it's using the Drizzle ORM, and it has very basic routes. It has a bunch of routes for orders. It has a bunch of routes for portfolios and stocks. Very standard API server. The cool part is how that gets represented in the Auth0 side. So I'm going to go to manage.auth0.com, and I'm going to swiftly log out because for the sake of this demo, I'm going to be using 2 accounts. That's 4-factor authentication. That was not the part of the demo. It's just my VPN. And so in an Auth0 tenant, this would be represented something around like this, right? Where you have an API server. You represent it as an API. How many of you are working on MCP stack right now, or either connecting to MCP or trying to offer MCP? Right hand for connecting to MCP, left hand for offering MCP. Oh, great. So in this section, you could also represent resource servers. And today, for the sake of this demo, it has my stock web app, and it has a bit more. So the first thing we're going to do is we're going to create a second app, which is our agent. And at the start of this demo, this agent actually has no tools, nothing, right? So I can just say, hey, are you functional? And it works. It's a Next.js start agent that I wrote in Vercel SDK. So if you're following along, I do leave out the code in .back.ts so that you can just cheat and move forward. All this code in this entire repository is Terraformed. So if we were to follow along, I would have been asking folks to sign up for an Auth0 tenant and then run Terraform because that would skip all the clicking. Or you can click. The workshop can go either way. So the first thing I'm going to do is I'm going to give it some tools. And the most basic tools that we can give it, because we already have a stock API, we can give it tools for, let's say it can search for stocks and it can get some stock prices, right? So I'm going to copy that over. And there's that. And I think I don't even need that one. I'm going to skip this part for now and just return just do this without that. And so for now, our stock agent should be able to start asking for stock price and stock info, right? So if I go back to the agent now, and I'll include the ... public stock tools, I can now ask it, hey, what's the stock price for Wayne? And behind the scenes, it's just going to make a direct call, and, well, the demo gods are not with us. Let me just check what happened there. Well, this is going to become a live debugging session in this way. So now I'm just going to add authentication to the agent and just skip the whole thing. If that doesn't work, I'm probably just, yep, there we go. So I'm sorry about like this, because if we do the step by step, it's easier, because I'm jumping way too far forward. I'm just going to go into problem space. I'm sorry about that. So effectively, what we're going to do first, what we would have done first, is we would have given it public tools. And when it's making a call to an API backend using a public tool, it does not need a credential. It does not need an access token. It does not need any sort of way to authenticate. Maybe you could give it a machine-to-machine for rate limiting. But ideally, when you connect a public tool, there's no authorization or no access control required, right? And so at this point, the agent can fetch prices for you, but the agent can't actually do anything on your behalf. And that's where one of the problems that we're starting to face is almost everyone is building agents that roughly look like the one I just fully fast forwarded. And you start with your front end, back end, and worker. You give it memory, you go spend a lot of money for NVIDIA inference, and then you start writing tools. And there's a couple of notes that I always mention. Do not pass the access token to the LLM. It should never have access to a credentials that's in plain text in the inference space. But that does happen, and we have seen scenarios where it either got privileged credentials or it just got keys to another thing, and it just ended up making the call. What also happens is every single time folks are trying to write a tool, they have to custom write each and every tool. And MCP has solved this to a large extent. But still, if we are looking at internal APIs, a lot of internal APIs are not really protected with user credentials or any credentials. And those tools end up being very, very root privileges, as well as they can do damage. Like in one scenario, there was a database vendor who had a agent that was configured with the same credentials as support. You could social engineer the agent into giving you access to someone else's tenant. So those are actual problems. And what we're trying to solve here for first phase is we're recommending that instead of trying to build the tools, abstract the authorization and especially token delegation part out of the tool calls and abstract it as like maybe one function. So one of the things that we're recommending, and this is all OAuth, right? So all of my demos use OAuth themselves, and we have some syntactic sugar for it, but this is just token exchange. So what Auth0 can do in this scenario, and I glanced over it very quickly, but I'm going to break this down for now. Auth0 can connect to any of the previous, like on the left-hand side, any of the identity providers. And these all issue credentials that are on behalf of the user. We can also facilitate delivering them on the other side. And if you're using any OAuth OpenID Connect compliant identity provider, they can all manage credentials for you. What this means is if you're writing an agent today, it's much easier to offload that token, the part of obtaining delegated access, as well as granting access to an authorization server. And so in the demo, which I'm going to switch back to, what we had done is the stock app itself does not actually live in the same tenant as the stock API. So our trade agent lives in a completely separate tenant. And what we had done is we had added a enterprise, or it's called enterprise, but it's just a connection. What we had done is we had given it an upstream identity provider. Okay, so what we did is we went to the OpenID Connect, and what we did is for the stock API server, for this agent, we actually created a connection in Auth0. So this has the root credentials, well, the root identity provider, which is stock.workshop.us.auth0.com. We added an authorization endpoint for it. We added a token endpoint for it. It has its jocks. And we configured the scopes we want access to. If I click the try button here, what it actually does is it makes a request to the upstream identity provider. So I'm on stock workshop, Shrek stock workshop, and not the GenAI tenant that I was using. The second half of what we've added there is we add support for this token vault. So when we obtain a refresh token, we'll keep the access tokens managed for the application. So in case when I do something like, can you fetch my portfolio? Behind the scenes, this agent is actually asking Auth0 for an access token to call the stock API, and then that makes the actual call to the stock API. And what I'm going to do, because my demo has been going all over the place, is I'm going to just log the token so that we can actually look into what exactly is happening. So if I go to console.log, token, and now I'm going to refresh and make it do that again. Hey, can you fetch my portfolio? So if I go back to the console, if I take this access token, there are a couple of things that I want to call out. It was issued for api.stocktrade.example. That's not an API that exists in this identity domain. It's an upstream identity provider's API, which only exists for the stock provider. So in this scenario, the agent has no access to the API without being explicitly granted. And two, it was issued with very specific scopes that allow very specific permissions to the agent. Consider a scenario like this one, where if I had told the agent to go monitor my stock, in order for this to work, the agent can tell me like, yes, I'll do this, and it can continuously keep pulling the stock. Or what it should do is it should start a worker thread. In the worker thread and the front-end application are not the same thing. There is a security boundary that you're jumping between the worker and your interactive client. It will now keep calling the stock API every now and then. If it sees some stock has dropped, it will try to make a sell transaction. At which point, the stock API might respond with, this is not good enough for me because I don't like the fact that you're trying to sell a stock and I've never seen this IP, or this just looks suspicious. This is a pretty common scenario that happens in banking transactions. Most of us get like that confirmation code. At this point, the worker has to now request human approval. But when it does so, that human approval cannot come from the worker, because the stock API cannot just trust the worker. This needs to be independently validated between the stock API and the worker. And so in this scenario, SIBA is one way to do this, but there are other OAuth grants that also become available, where what you could do is you could go from the worker and request approval to the stock API, and the stock app would connect the dots. And those are the things that I wanted to kind of like highlight, but since my demo is like halfly working, I'm just gonna go over them in parts, right? So when we added the portfolio tools, this is roughly what happened. I ask it to do something, it goes, gets the token from the token vault, it calls the vault API, and it returns. At this point, the exchange is governed through on behalf of, but behind the scenes, Auth0, if the token had expired, would have actually ended up calling the other tenant or whichever OpenID Connect provider we had. And what this allows us to do is, in the end, the credentials never leave a secure storage system, and they're always available wherever you're using them. We start with something like this, right? Where the stock scenario, and I've gone through it over it again and again. Everything is first party here. In the example that I just gave for StepUp, most banking apps do that. The challenge becomes when you want to do it for MCP, but the same flow also works for MCP. So imagine if this was Claude code, or Claude in general. Claude could obtain a token for the MCP server or the stock mcp.stock.example. And when it needs to go ahead and call the backend API, it can then itself try to perform those transactions. And because your MCP server is something that you control, you can write first-party code there. So in case of the CEBA grant, you can't really trust the agent to be truthful. But this was modeled as an MCP scenario. Your MCP server could actually make the call to the identity provider to actually delegate this. And that also works for any APIs. This is a pretty common OAuth standard, which is known as on behalf of. And roughly what it does is on the stock MCP server, you ask for a different audience and you exchange it. And so you can keep cascading them until you have the assurances that you need. I'm really sorry about the workshop just not working, and I was hoping to do certain things, but I think I can actually Q&A at this point.
So basically, if we have an API key, we can always coding to make our own MCP server standard for ourselves, right? So we customize it. So we can save our MCP server in my container or in my cloud. Will that we still have a risk? And what's the limit if I do it this way?
Are you talking about local MCP or remote MCP in that case? Are you connecting it over STDIO or HTTP?
This is a good question. I'm not. Can you explain to that?
So MCP, if you're using something like Claude or if you're using VS Code, it can connect to the MCP server in two ways. One is it can start a child process, and then it's just talking over standard input and output. And the other is it can try to make an HTTP request, which is to another server. And then it's hitting over network. If you're fully running it with Docker in your own containers, that's very different than if, let's say, in an enterprise environment or something like mcp.github.com. That would be a shared public environment. So which is the scenario that you're trying?
Oh, I see. For example, I just give you an example, okay? For example, there's a 3D Blender platform, right? I have their API key. I use their API key. I just hard coding to create my own MCP server. So I save my MCP server on the cloud. So everybody can use this. Then I can use my MCP cloud to ask their API.
So in that case, if you hard code your API keys, how does it differentiate between if I try to access it or if he tried to access it?
Yeah, that is also, I think it's limited. I think we'll maybe give each person a different role. Each person have the different functionality to do it.
And in that also, even in that case, how does the MCP server know who it's talking to?
I'm thinking about also I can save it in the container, so I can give each person a role.
Oh, so in a web container, you have some kind of a provisioning where each person gets their own separate container?
Yes. How about like that?
That is a potential possibility. What I would recommend for that would be outside, it's not governed by OAuth, but then you're talking over you're trying to do it over. So MCP as a protocol also allows you to do custom transports. That to me sounds closer to custom transports where you have a dev container and you have some sort of a hosted environment that's available to only that person, right? So you have some kind of an enterprise managed system which fully separates out the MCP, it fully abstracts out that he cannot access my MCP container. Is that what the assurance that you have?
That is also what I'm thinking how to do it.
So the way I would recommend doing it and the way we are doing it ourselves internally is in the enterprise world, there are two types of MCP clients. One is the one that you built yourself. So if you wanted to write an internal app for your own internal employees, you would know, you would have an identity provider, right? You sign in with Okta, you sign in with Azure AD, you sign in with any sort of like a corporate identity provider. You could leverage that identity provider to obtain a credential for them.
Yes.
And so that would be one half. The other would be if you're inside your enterprise, you have something like VS Code or Cursor or Windsurf. Either of these clients are no longer built by you. They are built by third-party companies that are trustable, but they're not like, you can't influence the source code there. And so for both of those scenarios, what we are recommending is you should model that as like an internal MCP gateway. So you have like a proxy MCP server, because the interesting thing about MCP is that protocol allows for you to add an entire additional MCP server in front of an MCP server, and you can combine it that way. It could be a transparent proxy, and there's a product called, I think, whataboutyou.ai. I think they have a Unia. They have an MCP gateway. I think there's a STO proxy as well. And what all of these products do is they're trying to enforce this layer, and I'm just going to try to draw this. Oh. I'm just going to walk. Did it work? No. Oh. So imagine like your internal workforce provider is sitting here, right? And what you probably want to do is, and this is just using Auth0, but it could just, even if it wasn't there, that model would be the same. You assume that the AI agent is completely third party. And you always assume that the only place that you control is a first party MCP server you're writing. Now, this MCP server itself can call backend servers or other MCP servers. So what you can do is you can rely on your primary identity provider to issue you a token for this that only grants it access to the MCP. So the example would be, let's say I want to grant access to Jira. So this is Claude. It wants to see my Jira account. When Claude makes a request to access Jira, this credential is only good enough for it to call your MCP gateway. From your MCP gateway to Jira, your first-party corporate identity provider can actually facilitate that exchange. And so that's one way to model it. That's something that we are doing internally ourselves because we have Token Vault. So we can just use Token Vault to almost ensure that all of OAuth credentials do not end up in the third-party client. And they're usually held either in the Auth0 Token Vault or some kind of a secure infrastructure. Maybe it could be closer to the MCP server as well. But that's how I would model it. Instead of trying to containerize it, because then you would need almost operating system levels of assurances. That way, even if this was any third-party client, you could then control that. And the second thing that the MCP spec itself might be going towards is, I don't know if you were following the MCP spec, but there is a new standard that's being pushed now, which is called the OAuth client ID metadata. Today, if this agent wanted to talk to this MCP server, it would have to register its own new credentials here. And this server has no idea who this agent is. With OAuth client ID metadata, this agent has a document that it hosts. So you could say something like allow VS Code, allow Claude, allow Cursor, but do not allow anyone else. And with those two, you would be able to get with that standard, you would be able to get enough assurances to protect your internal resources.
Thank you so much. That's really clear. Thank you.
I had a question. Thank you. I had a question about how much you can trust an AI agent with confidential data. So obviously you just mentioned that you should never give your credentials to an AI agent because they can be prompted, they can be whatever to gaining access to those credentials. But are there any techniques for, say, I don't know, passing encrypted credentials to an AI agent and then having the API that the AI agent talks to decrypt those credentials? Any techniques like that?
One of the simplest thing we could do, and again, that's my personal opinion, but when we're talking about MCP servers, they're net new. They do not exist, right? And so they have like this fresh new cadence of like writing software in a way that we have never done before. Because MCP servers require the protected resource metadata endpoint. If you're unfamiliar with protected resource metadata, it's a OAuth spec, which roughly translates to the server itself, whichever one is being protected by the OAuth client, gets to host a document that says who it's going to trust and where its keys are. Because you have that assurance now, especially the fact that it can host its own JSON web keys, it's now very, very, very easy to have a bearer token that's a JOT, but it's encrypted because we have a very clear way to get its public key. So we can always encrypt that at the token level. Beyond that point, limiting information by MCP is going to be, it's going to be a harder problem than just like, redaction. And let me give you an example. Imagine if like some meeting was happening and you had like this document that had internal sales numbers and that was on the screen for 10 minutes. Your average salesperson would know that that needs to be redacted. And they might leverage that information to, hint towards a more positive outlook to a customer, but they're not going to, say the whole thing as is. That's a very blurry line which an AI agent cannot infer, right? Because it's just data. And it has consequences. So it needs to understand that this is a sales figure. Now, we can train, we can prompt, we can add redaction, but in case of sensitive data itself, depending on what that data is, what I would recommend is if it needs to go from your controlled assets to your controlled assets, use JSON Web Encryption so that at the very least the third parties don't see it. When it comes to returning data from MCP servers, try to limit it because it's context engineering. It's the best practice to reduce context as much as you can. You should be able to make tools that are slightly different levels, right? So you don't disclose someone's entire profile information. You only disclose maybe a one-way hash, right? Those are some techniques that you could use, but overall, depending on what sensitive data it is, like if it's someone's medical health information, I would not send that to an inference stack unless I control that inference stack, right? If it's someone's banking records, that's a different conversation. So do you have any specific scenario on that sensitive information?
No, I was just spitballing. Thinking about what might be an issue.
You could potentially use fine-grained authorization, something like Zanzibar or FGA, to limit the documents that people have, but I would be very curious to see how that grows into just inside a paragraph. There could be interlaced information. So I would be more curious to see how that grows, because you can't really redact per token yet. You would have to almost hand redact the document, and at that point it wouldn't scale. But when you're writing tools, I would assume that here, when you're exposing tools, don't just forward the API data as is, because your first-party clients tend to have a lot more information than they render. A lot of times when we'll talk to someone and we'll open up their access token, we'll see like people's addresses, because the first-party client uses that address to give them a good deal. A third-party client is going to use that for tracking, and that's information disclosure. So as we move more and more towards talking to third-party clients, one thing the MCP server can do is, it's not going to be automatic, but at the very least, the newer tools and the newer resources allow us to limit what we're sending back. But once it's exposed, I don't think there's anything we could do in that case.
Gotcha. Thank you.
So this architecture you said you guys are using internally, right? But out there in market, is somebody already using it?
There's some, I mean, I think Anthropic itself uses an internal MCP proxy. So they have like an MCP library, which so if you want to talk to Jira, it will be internal / Jira. And that MCP library does very similar stuff where all of the OAuth credentials and all of sensitive credentials are managed by their SDS or token cache. Mm-hmm. They're never visible to every single developer or every single tool's client, right? Because their way of modeling that is this internal MCP library almost forwards the MCP protocol for every single client. So the internal employee connects their access to Jira, and now any client they build, they just need to be able to add this library and leverage it again.
Going to the applications, and I think linking with the previous question about who would trust the new architecture, as in it's a new idea right now. Some of the examples, I think you mentioned a good example with the stocks. I think healthcare reports would be another one. Is there any platform using this method for sharing that kind of sensitive data as of yet, or it's still under discussion? Or
I mean, it's roughly what Zapier does. Zapier is roughly doing the same, where you're connecting to Zapier, and then Zapier is connecting to everyone else.
Okay.
That's very similar, if I understood your question correctly.
Yeah. Just
it's also like Pipedream does similar. It's like there's a lot of like MCP wrappers that are gonna offload like token minting or token vaulting as well as API calling. But I think that there's a lot more work that needs to be done. But the closest example is like, let's look at how like ChatGPT or Claude themselves call APIs. If you go and sign into a ChatGPT integration, your access token is never on the ChatGPT client, right?
Okay.
The access token to Jira, if you're accessing ChatGPT through Jira, only lives within ChatGPT servers. So ChatGPT itself has a vault where they're storing your credentials. And that model works very well because there are two problems that happen if you try to make it go to the client. One, if you picked up your phone and you want to talk to it on your laptop, you don't have to authenticate twice. You only authenticate ChatGPT once. And two, if your phone gets stolen, your Jira credential also does not become vulnerable. In that case, even in the ChatGPT credential, which is the least privileged entity in that chain, is the only thing that's on your phone. So from a breach point of view, it also limits the blast radius, because what you will notice is, let's say there was something that stole your refresh token or access token, and it wants to do something malicious. That attack pattern would look very different than you normally using ChatGPT. So there's another additional advantage there too, because you're gating that token completely outside the untrusted client.
Yep. Thank you.
Well, folks, I'm very sorry about the finickiness of my stack, but I am available to chat about Auth and Okta and Auth0. We're trying to release several products. One of them is Token Vault that we talked about today, and I did a very quick, short demo. I wish that we'd have done more code so it would be slower, but what I would love to do is I would love to hear the problems that you guys are facing when you're building your applications, especially when agents have to access data, or agents have to access credentials on someone's behalf, or when they have to do sensitive operations, like the stock trade example. If it needs to sell stock, it must get human consent in some cases. Those are problems that we're going to see a lot more as agents touch more and more of the software we use today. Like today, there's only 79 remote MCP servers and about 6,000 local ones that you have to pass API keys to. I would assume that we would have 6,000 remote HTTP servers by the same time next year. And that means there are 6,000 services that can now talk to each other, because from one MCP server, you can talk to another, and the MCP server itself can be an inference client. So there's a lot of nesting that opens up, and I would love to hear if you're building applications that are into that space and how we can help. That's all from me for today.